Okay, so we're going to continue talking about simplifying complex fractions. And remember, in the previous lessons, we talked about using method 1 and we talked about using method 2. So it's important you go back to those lessons and remind yourself, for example, lesson 1, what does that mean? What does using method 1 mean? And remember, what that means is that you're going to rewrite the numerator as a single fraction, and you're going to rewrite the denominator as a single fraction, and this is the work we went through. And then you change the division problem to a multiplication problem. All right, and then in method 2, that's where we found, in method 2, that's where we found the least common denominator of all of the fractions in both numerator and denominator. And then you multiplied every term in both numerator and denominator by that LCD. And then you went from there. So that's the difference between method 2. So just in method 1, so just make sure you go back and you review those two methods. Now in this lesson, basically what's going to happen is you're going to be given some complex fractions and you're going to be asked to simplify using either method. It's very important, though, for your success that you understand how to do both. So both methods are important to learn. Okay, so let's start with a simple example. So we can look at this example again where we have a complex fraction. Remember, a complex fraction is where you have one or both numerator and denominator having fractions in it. Okay, so if you look at this, we're going to go ahead and look at it in terms of method 1. So I'm going to do method 1 first. I'm going to try and do all of these, if possible, using both methods, just to remind you how to deal with it. So method 1, remember, says this. So method 1, so this is in your Canvas information. So method 1 says you rewrite the numerator and rewrite the denominator as a single fraction. So if you notice that the numerator is already a single fraction, the denominator is already a single fraction. So step 1's already done. And so then you just go ahead and you change this to a multiplication problem. That's step 2. So for this problem, the question would be, is it easier to do number 1 using method 1 or method 2? Whenever the problem already has a single fraction in both cases, numerator and the denominator, then method 1 is the easiest. Because all you do now, watch this, all you do now is just change this to a multiplication problem. So this becomes negative 2/9 times the reciprocal of the denominator, which is a negative 3/14. And then remember, reduce first if you can. So negative 2 divided by 2 is a negative 1. That can reduce with the denominator. So that's 7. So 14 divided by 2 is 7. The negative 3 and the 9 I can reduce. So negative 3 divided by 3 is a negative 1, and then 9 divided by 3 is 3. So then I get a negative 1 times a negative 1 is a positive 1, and then 3 times 7 is 21. So you get 21. Okay? So that is method 1. Now if I had done method 2, I want to just show you what would happen there. Okay, method 2. So method 2 is where you find the least common denominator of all your fractions in both numerator and denominator. So if I look at the numerator, I only see one denominator, which is 9. And if I look at the denominator, that denominator of that fraction is 3. So the LCD is 3. So in other words, if I go back and I rewrite the problem, and then I circle the denominators, those are the denominators of both numerator and denominator. Those are the denominators of the fractions that are in both numerator and denominator. So the LCD here is 9. So then what you would then do is this. So once you find the least common denominator, then step 2 says you multiply the numerator and the denominator, every term of the numerator and every term of the denominator, by the LCD. So in other words, I'm going to go ahead and rewrite this over. So in other words, you get this. You get negative 2/9 divided by negative 14/3, right? So I'm going to say times 9 times 9. Okay, that's what step 2 says. And then the next step is to simplify. So if you're doing this correctly, whenever you do step 2, remember at this point, that's where these denominators that you have circled should now be factors of 1. And it will, watch. 9 divided by 9 is 1. 9 divided by 9 is 1. 3 divided by 3 is 1. 9 divided by 3 is 3. You see, you get 1s now. And so now you get negative 2 times 1, which is negative 2. And then negative 14 times 3, negative 14 times 3, which is, use your calculator if you need to, which is negative 42, right? And then simplify this. Now they're both even, and then also notice that a negative divided by negative is a positive. So since they're both even, they're both divisible by 2. So 2 divided by 2 is 1. 42 divided by 2 is 21. So you get the same thing. So notice, though, that method 1 was a lot easier than method 2. Okay, method 1 was easier than method 2. So whenever you already have a single fraction divided by a single fraction, then do method 1. But it is important that you understand both processes. All right, so let's look at number 2. So number 2, let's suppose we had this for number 2. Let's suppose we had 2 plus 6 divided by x, and that's being divided by, let's say, 1 minus 9 divided by x squared. Okay? And so let's do method 1 first. So we're going to do both methods just to give you an idea of how to deal with this. So method 1. So method 1, remember, is where you look only at the numerator first and you write this as a single fraction. And then you look at the same thing at the denominator, right? This is a single fraction. So that's where, if you recall, if you go back to our lesson on method 1, that's this part here. That's where you took this, wrote as a single fraction, took this, wrote as a single fraction, and then you brought it back here. All right, so that's method 1. So given, now listen carefully, so given the choice between method 1 and method 2, this would probably be easier to deal with using method 2, okay? Using method 2, because you have a bunch of fractions here. Whenever you have a bunch of fractions, it's probably quicker to use method 2. All right, so let's go ahead and do both those. So let's do method 1 first. So method 1, remember, you take the numerator, which is 2 plus 6 divided by x, and you got to write it as one fraction. I'm going to write the 2 as 2 over 1. So the LCD here is x. So I'm going to write 2 rational expressions with x as the denominator. So the question is 2 divided by 1 is equivalent to what fraction with a denominator of x? So notice I got to multiply this by x, and what I do to the denominator, I have to do to the numerator. So 2 times x is 2x, so that goes here. Okay? Over here, this is an x, this is an x. So remember, every rational expression is equivalent to itself. So that's just a 6 here. Since the denominators are the same, the numerators have to be the same. And it kind of makes sense, because if you do the same thing you did here, you'd say x times 1 is x, 6 times 1 is 6, right? Okay, now I can write this as one rational expression. So this becomes 2x plus 6 divided by x. So that's this part here. So that's 2x plus 6 divided by x. Then I look at the denominator now. So now we go to the denominator. So if I go to the denominator, I have 1 minus 9 divided by x squared. And so I'm going to write this as 1 over 1. And so the LCD here is x squared. And so I'm going to write 2 fractions with x squared as the denominator. And so I got to figure out, I have a 1 here. I want to get an x squared. So 1 is equivalent to what rational expression with x squared as the denominator? Now remember, you see, that's 1, right? So anything divided by itself, any expression divided by itself is 1. So if this is x squared, what do you think this should be? That should be x squared also, because that's the only way you can get a 1. So notice, though, this is what you did. You said 1 times x squared is x squared, and then 1 times x squared. So remember, what you do to the denominator, you do to the numerator, that's x squared as well. Now this, I already have an x squared, so that has to be a 9 here. Okay? And so therefore the denominator, so therefore I can write this as one rational expression, so that's x squared is my denominator. And so I get x squared minus 9. So that's that right here goes here. So x squared minus 9 divided by x squared. So now once you write it as a single fraction divided by a single fraction, then you change this to multiplication problem. So then I get 2x plus 6 divided by x times the reciprocal of the denominator. So that's x squared divided by x squared minus 9. All right, now remember, just like you did in previous lessons when you multiplied rational expressions, you got to factor first. So when I factor, and it's always a good idea to rewrite it, when I factor the numerator here, I can factor out a 2 to get 2 times x plus 3. The denominator stays as x. The numerator here is a monomial factor, so that's going to stay as x squared. The denominator is the difference of two squares, so I can factor this as x plus 3 times x minus 3. Okay, and now let's reduce. My first factor I see is a 2. I don't see any factors of 2 in the denominator. The next factor I see is x plus 3. I see one here, so I can reduce that. I can simplify that. I can divide those out. The next factor I see is 2 factors of x. I see one here, so I can factor out, or I can reduce one of those. And so that's all you can do. So the answer will be 2 times 1 times x, which is 2x, divided by 1 times x minus 3, which is x minus 3. All right, so that's the answer. Now notice that this is method 1. That is method 1. Okay? All right, so notice to go from here, given this, using method 1, we had to first of all take the numerator, write it as one rational expression, take the denominator, write as one rational expression, that's this, and then change the multiplication problem, factor, and then reduce, simplify. Okay, now let's do this method 2. So let's do the same problem, but this time we're going to use method 2. So let me go ahead and rewrite this over using method 2. All right, let me go ahead and make this a little bit smaller. All right, so let's rewrite the problem. So this is 2 again, and we have 2 plus 6 divided by x divided by 1 minus 9 divided by x squared. And so if I use method 2, so this is method 2 now, method 2. So method 2 is where you look at all your denominators. And remember, let's go ahead and rewrite this as 2 divided by 1 plus 6 divided by x, and then 1 divided by 1 minus 9 divided by x squared. And so method 2 is where you look at all your fractions in both the numerator and the denominator and find the LCD of the denominators of those fractions. And so if you look at those 4 things I have circled, the least common denominator of 1x, 1 and x squared is x squared. So the least common denominator is x squared. Then once you do that, remember the next step in method 2 is to multiply each term in the numerator and each term in the denominator by the LCD. So that means this. That means I'm going to rewrite this over. So that means that you're going to multiply numerator and denominator by x squared. Because remember, what you do to the numerator, you do to the denominator, and then you distribute. And that's where step 2, when it says multiply each term in the numerator and each term in the denominator by the LCD, that's what happens when you distribute. So basically you're saying 2, and I'm going to write this as just 2. 2 over 1 is just 2 times x squared plus 6 divided by x times x squared divided by, so each term, you see each fraction, and you had 4 of them, is being multiplied by x squared. See that? And then 1 times x squared minus 9 over x squared times x squared. Okay? Then once you get to that point, remember in previous lesson, then you're going to reduce. Remember the whole point of multiplying by the LCD is to get these denominators to be 1s. So notice that this is an x, so since I multiply by the LCD, when I reduce, that better be a 1, and it is, because x divided by x is 1, x squared divided by x is just x. You have one factor of x left. Over here, both factors of x divide with both factors of x here, and you're left with factors of 1. Okay, and so therefore we get this now. So we get 2x squared plus 6 times x is 6x divided by, and then over here we get x squared minus 9. Okay? And so now, remember, before you say that's the answer, remember you got to make sure you simplify if you can. So I got to factor both the numerator and the denominator. That's the next part. So when I factor, I can factor out a 2x, and I get 2x times x plus 3. And then over here, I factor the denominator. That's the difference of two squares. I get x minus 3 times x plus 3. And then I reduce. And the only thing I reduce here are the x plus 3's. And don't forget to put factors of 1 in their place. And so you get 2x divided by x minus 3, which is your answer. All right, so that was method 2. So remember method 2. So this was method 1, and this is method 2. All right, you get the same answer. It is very important. It's very important that as a student, you know how to use the different methods, both methods on any problem you may have. Okay, because the directions may say use method 1, directions may say use method 2. All right, so it's important to know how to deal with it in both ways. So let's do number 3. Let's do another. So this will be number 3. So number 3, let's suppose we had this problem. Let's say we had 3 minus x divided by y divided by x divided by y minus 3. So let's suppose we had that. Okay, so again, we're going to do it both ways. We're going to do method 1 and we're going to do method 2. All right, so method 1. So method 1, remember that's where you take the numerator and you write as one fraction. So that means you go off to the side and figure out what the LCD is of those two fractions. So the LCD is y. And so I'm going to write two fractions with that denominator. Now notice that these denominators are both the same, so every rational expression is equivalent to itself. Over here, though, I have a 1, I need a y, so I'm going to multiply this by y, so I'm writing equivalent fractions. So 3 is equivalent to what fraction with y as the denominator? So whatever I do to the denominator, though, I got to do the same thing to the numerator, so I got to multiply the numerator by by y, and so you get 3y. So now we have 3y minus x in the numerator divided by y. So that's going to be this part. So this is going to be 3y minus x divided by y. Then we do the same thing with the denominator. So with the denominator, I have x divided by y minus 3 divided by 1. So again, the LCD is y. And so I'm going to write two fractions with y as that denominator. And so notice that these are already y's, the denominators, so every rational expression is equivalent to itself. So the denominators are the same, the numerators have to be the same. And then here, I need to multiply, to get a y, I need to multiply this 1 by y. What I do to the denominator, I do to the numerator. And so I get 3y here. So then this becomes x minus 3y divided by y. So that's this right here. So x minus 3y divided by y. So now once you get to that single fraction in both numerator and denominator, the next step is to change this to a multiplication problem. So it's the numerator times the reciprocal of the denominator, just like this. Okay, and then you reduce. Okay, so if I look at the numerator, 3y minus x, you're going to say, all right, the GCF is 1, so I can't do anything with that. Here, those are monomial factors. So I'm going to leave them as monomial factors. Here, the GCF is 1. Can't do anything with that. Okay, that's fine. But what don't you notice? You got to remember the idea of opposites, right? So if you look at this, 3y minus x, you may say, well, I don't see 3y minus x in the denominator, but I see its opposite, right? So the opposite of 3y is a negative 3y. The opposite of negative x is a positive x. And so remember, when we dealt with that, we said that when you divide opposites, you get a negative 1 as its factor. So we made the denominator positive 1 and the numerator negative 1. Okay? And then the y's divide out, and so you just get negative 1 times 1 is negative 1. 1 times 1 is 1, so you just get negative 1. There's your answer, negative 1. All right? Now if I use method 2, let's talk about method 2. Okay, method 2. So I have this problem again. So I'm just going to go ahead and rewrite it. So 3 minus x divided by y divided by x divided by y minus 3. So remember, method 2 is where, I'm going to write this as 3 over 1 as well. Method 2, remember, is where you look at all your denominators in both numerator and denominator, all the fractions in both numerator and denominator, find the LCD of all the fractions listed. So the LCD is y. So once you find the LCD, then you're going to multiply both numerator and denominator by that LCD. So every term, every fraction be multiplied by y. Okay? So that's what's happening. Every fraction is going to be multiplied by y. So here's what we get. We get 3 times y minus x over y times y, right? Divided by x over y times y minus, and that's just 3 times y. Now if I reduce, see these y's divide out. Remember that's the whole, all these when using method 2, all of these expressions that have circled, all those denominators, you at some point you need that to be all ones. So this is a 1, this is a 1, these are not. But notice what happens. When I reduce, when I simplify, I get ones in their place because the y's divide out. Same thing here. So then what I end up with is this. I get 3y minus, and then x times 1 is just x, so 3y minus x divided by x times 1 is x minus 3y. And then notice, now the GCF in both of these is 1, but notice that those are opposites. So when I divide opposites, this is a 1, this becomes a -1, and so you just get -1. Okay, so that was method 2. So sometimes when you have 4 fractions like this, sometimes method 2 may be quicker at times, right, depending on what you have in the fractions. Okay, so let's look at another one. So this will be number 4. So you see, it's not that bad. Just knowing both methods does help. Knowing both methods. So number 4. So number 4, let's suppose we had this for number 4. Let's suppose we had 3 divided by 1 minus 4/3. Okay, so 3 divided by 1 minus 4/3. Okay, so you have, now notice there are no variables here, so it's just an easy complex fraction to deal with. I just wanted to bring that up again. So notice though that if I use method 1, now before we go on, which one do you think might be easier, method 1 or method 2? All right, well, let's see. So I probably would think method 2 would be easier here, and you'll see why. But let's look at method 1. So method 1 says I have to make sure that each numerator has a single fraction. Now this is already a single fraction, right? Because that's 3 over 1. Okay? But the denominator is not a single fraction, so I got to go off to the side and figure out what 1 minus 4/3 is as a single fraction. So 1 is 1 divided by 1. The LCD is 3. So I'm going to write 2 fractions with that LCD. And then remember, some of you can skip this step because many of you know that 1 divided by 1 with an LCD of 3 is just 3 over 3. So you have 3/3 minus 4/3, which is a -1/3. So you probably knew that already. So you didn't have to do this work for that kind of problem. But remember though, if you do need to do this work, and there's nothing wrong, some of you may need to do this work. So because you need to actually see yourself writing this out. So if you write it out, you think about it. So 1 times 3 is 3, because you wanted 3 right here. And so 1 times 3 is 3. So that's 3 divided by 3. And it kind of makes sense because 3 divided by 3 is 1 divided by 1. These denominators are already the same, so the numerators have to be the same. So remember, every rational expression is equivalent to itself. And so therefore, 3/3 minus 4/3 is a -1/3, right? So that goes here. Then, now once you get a single fraction divided by a single fraction, then the next step is to change this to multiplication problem. So I get 3 divided by 1 times the reciprocal. The reciprocal of -1/3 is a -3 divided by 1. And so therefore we get, now remember you can't reduce here because these are 1s in the denominator. So all you do now is just multiply the numerators together. 3 times -3 is a -9. 1 times 1 is 1. So you just get -9. That was method 1. Now if you do method 2, let's see what happens with method 2. So method 2, same problem. I'm going to write the same problem over. 3 divided by 1 minus 4/3. Now I'm going to rewrite 3 as 3 over 1, and then 1 over 1 minus 4/3. Okay? And so notice you have 3 fractions altogether, right? 1, 2, 3. I'm going to circle the denominators. Now, of those denominators that have circled, what's the LCD? So the LCD is 3. So now what you're going to do is you're going to multiply, and we're going to rewrite this over. And I'm going to rewrite it to where the 2 ones here aren't listed. So now what you're going to do is you're going to multiply both numerator and denominator by 3. Now notice I put that in parentheses because that's more than one term, because now you have to distribute. Here that's just one term. So I just know that 3 times 3 is 9, right? Now over here, if I distribute, I'm going to get 1 times 3 minus 4/3 times 3. Y'all agree? And then let's go ahead and reduce the 3. Remember the whole point, those things I have circled, and it's a good idea to have them circled, because when using method 2, those fractions, those denominators you have circled, at some point, they all better be a factor of 1. These are already a factor of 1. This is not. And it does now, because notice 3 divided by 3 is 1. 3 divided by 3 is 1. So now this right here becomes a factor of 1 because you multiply by the LCD. And so now we get 9 divided by 3. 1 times 3 is 3 minus 4. So that's 9 divided by negative 1, which is negative 9. And there's your answer. So that's method 2. So just again, notice that some of you may prefer method 1 here, some may prefer method 2. But the point is this. It's a good idea to know both methods. Know both methods. Just in case you're dealing with a problem and you try method 1 and you get stuck, then go to method 2. If you try method 2 and you get stuck, then try method 1. Okay, so it's a good idea to know both. It's very important. Okay, let's do one more. Let's do one more with doing both methods. So you see, it helps if you look at both methods for each problem. It does help if you look at it in that situation. So let's look at this problem. Let's see. Okay, let's do this one. So this will be number 5, I guess. Okay, number 5. Okay, number 5. Let's suppose we had this. We had 3 divided by x squared y minus 5 divided by xy squared divided by 6 divided by x squared y squared plus 4 divided by xy. Okay, so let's suppose we had that. Okay, so let's do both methods. Method 1. And so method 1, remember, is where you take the numerator, go off to the side, and write it as one rational expression. Okay? So look at your denominators. Your factors, you have factors of x, factors of y. So those are your unique factors. So I need some x and y. So the question is, how many do I need, though? I have 2 factors of x here. I have 1 here. So I need 2. Let's talk about the y's. I have 1 factor of y here, 2 factors of y here. So I need 2. So there's your LCD. So your LCD is x squared, y squared. So now I'm going to write 2 equivalent fractions with that LCD. So that's method 1. So now let's look at what we have. So I have this rational expression. I want to write an equivalent rational expression that has this denominator, though. So look, I have x squared y. I have all the x squareds. I only have 1 here. How many do I need? 2. So what is I got to multiply this by? I got to multiply this by y. So if you multiply the denominator by y, because y times y is now y squared, I have to do the same thing with the numerator. So what goes here? 3 times y. So this is 3y. For this one, let's see what we have. So I have 5 divided by xy squared. I want this as my denominator. So 5 divided by xy squared is equivalent to what fraction with this denominator? So I have the y squared. I need 2 factors of x. I only have 1, so I got to multiply this by x. So what I do to the denominator, I do to the numerator. So my numerator is going to be 5x. And so now I can write as one rational expression with that LCD. So I get 3y minus 5x. So that's going to be your numerator. So that's your single fraction. So that is this. So that's 3y minus 5x divided by x squared, y squared. Now let's do the denominator. So my denominator, you have this now. You have 6 divided by x squared y squared plus 4 divided by xy. So if you find the LCD of those two fractions, I have factors of x and y that I see. So I need some x's and some factors of y. The question is, how many do I need? I have 2 here factors of x, 1 factor of x here because that's x to the first. So I just need 2. You got to use the maximum amount that you see. For the factors of y, I have 2 here, 1 here, so I need 2. So there's your LCD. So now you're going to write 2 fractions with that denominator, x squared, y squared. All right. Now, we're going to write equivalent fractions. Now, I want you to notice, see, this denominator is the same as this. So there's nothing I need to do here because I already have this is equivalent to itself. So 6 divided by x squared, y squared is equivalent to 6 divided by x squared, y squared. Here, though, this is not this, so I'm missing some factors here. So notice I have 1 factor of x. How many do I need? 2. So that means I got to multiply this by x. I have 1 factor of y. How many do I need? 2. So I got to multiply by a factor of y as well. And that kind of makes sense because x times x is x squared, y times y is y squared. But what I do to the denominator, I have to do to the numerator. So I got to multiply the numerator by xy as well. So the numerator becomes 4xy. And so now this becomes one rational expression, one fraction with that denominator. I just got to rewrite the numerator. So that'll be 6 plus 4xy. So that goes up here. So 6 plus 4xy divided by x squared, y squared. All right, now notice all the work you had to do. So there are many places in here you could have easily messed up. So always double check your work because you don't want to do something and then all of a sudden you put it here and then it's all wrong because of one little thing here. So just be careful. It's very easy to kind of miss something. Okay, so now once you get to one single fraction divided by one single fraction, you're going to write it as a multiplication problem. So the numerator, 3y minus 5x, divided by x squared, y squared, times the reciprocal of the denominator, x squared, y squared, divided by 6 plus 4xy. Okay? And so now, notice we got to factor any polynomials with more than one term. So 3y minus 5x, I can't do anything with the GCF is 1 here. I mean, I can factor out a 2, right? But that's not going to help at all, it looks like. All right, so now let's reduce. So I have a factor of 3y minus 5x here. I don't see 1 here. My next factor is x is a factor of x. I have 2 here, so all those can divide out. So I'm left with factors of 1. I have 2 factors of y here. I have 2 here as well. So all those divide out. You're left with factors of 1, and that's it. So the answer is 3y minus 5x times 1. 1 times 1 is 1. And so you get 3y minus 5x divided by, and then you can either say 6 plus 4xy, or you can say 2 times 3 plus 2xy. Okay, so that's the answer. All right, now let's do this method 2. So I need another sheet of paper for method 2. So notice that was method 1. I know it looks bad, but just practice with it. It's important you know the 2 different methods. So let's look at method 2. So this is number 5 again. We're going to look at this in terms of method 2. So we rewrite the problem. All right, so this was a problem, the original problem. And let's see. Okay, so we got to find the LCD. So notice that the fractions, the denominators are monomial factors. So there's really nothing to factor here. So I'm just going to circle all these denominators because they're all monomial factors. And so I just got to find the LCD of those 4 denominators that I have circled. So remember, your LCD must include every unique factor you see. So if I look at all of these, I have x's and y's. Question is, how many do I need of each? So let's look at the x's first. I have 2 factors of x here, 1 here, 2 here, 1 here. So how many do you need? 2. Always the maximum number that you say. For the y's, I have 1 here, 2 here, 2 here, 1 here. How many do you need? 2. So there's your LCD. Once you find your LCD, then you're going to multiply all of these fractions by it. But basically what's happening, we'll go ahead and write this over just to kind of show you. So that's x. So basically what's happening is that you're going to be multiplying both numerator and denominator by the LCD. So numerator and denominator by the LCD, just like that. And then you're going to distribute now, which is a part where, remember in step 2, that's the part where it says multiply each term in the numerator, multiply each term in the denominator by the LCD. And notice that's what's happening. Because look, this becomes 3 divided by x squared y. That's going to be multiplied by the LCD. Minus this fraction, 5 divided by xy squared, times the LCD. Okay? Divided by, same thing here. Multiply each fraction by the LCD. So 6 divided by x squared y squared times the LCD. Plus 4 divided by xy times the LCD. Okay? Now remember, when using method 2, remember all of these fractions, all these denominators I have circled, at some point when we do this part here, they need to become 1s. They need to become factors of 1s. And so they will, because you are using the LCD. Notice that x squared divides into x squared. 1 factor y divides into 2 factors of y, and you're left with a factor y. So that's a 1, that's a y. Over here, this factor of x will reduce. I have 2 here, so reduce with one of those. Both of these factors of y's divide out, so you're left with factors of 1 in their place. Both factors of x divide out, you're left with factors of 1s in their place. Both factors of y's divide out, you're left with factors of 1s in their place. Here, this factor of x divides with one of these, you're left with 1 factor of x in the numerator. Here, this factor of x divides with one of these, you're left with 1 factor y in the numerator. So there are lots of little red marks here, right? So be careful. So let's see what we have. So you've got to be careful though. See, these denominators are now all 1s. See that? They're all 1s. That's the whole point of multiplying by the LCD. So this is a 3, because 3 divided by 1 is 3. 3 times 1 times y is 3y. Minus 5 times x times 1 is 5x. Divided by 6 times 1 is 6. Plus 4 times x times y is 4xy. And notice you want to simplify this if you can, and you can't, because even if you factor out at 2, it's not going to help. So you can leave your answer like this, or you can factor out a 2 from the denominator, and you would get 2 times 3 plus 2xy, which is, if I can find it, which is this. See that? So this, let me kind of put it right here. So that is the same answer. Okay? So this is method 2. And this was method 1. Okay? So that was method 1. All right. So that's 5 problems that I think will help you to understand how to use both methods with each kind of rational complex fraction that you get. All right, so that'll be the end of this lesson.